Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy and we're continuing our series on applications of trigonometry by looking at the area of a triangle. In this video you're going to find the rule for a non-right angled triangle and how to find its area. We're going to look at a couple of worked examples and then derive the rule quickly for our senior extension students. Now you should know the rule of an area of a right angled triangle. We've been learning that one since about grade 7, and it's half times the base times the perpendicular height. Now with a non-right angled triangle we've got a new rule, half BC sine A. Now there's some new variables in there, the letter B, the letter C and the sine of angle A. B and C are our two side lengths as shown in this triangle on your screen, and A is the angle between those two sides. So you actually need that angle in between the two sides to be able to use this formula. So you need to also know your formula sheet. If you're in Queensland studying general maths or math methods, or Victoria, then you're going to look in different parts of your formula sheet. In Queensland you're going to look in the trigonometry section and you'll be going to be using the variables B, C and A. Then the angle A will be what you are doing the sine function on. If you're in Victoria studying further mathematics, however, you'll notice the formula looks slightly different. Instead it's angle theta instead of capital A, and you're going to be looking in a different part of your paper to the geometry and measurement section. If you're in New South Wales in maths extension and maths applications in Western Australia, you're using the same letters but in different orders. It's A, B, sine of C. Doesn't really matter, it's all about how you label your triangle. So if you're in New South Wales, you've got to look at the bottom of page 2 of your formula sheet, and if you're in Western Australia, finding that in the applications of trigonometry section. Okay, let's do some worked examples. First, we've got the very basic triangle here. We've got to find its area. Now, it's very tempting. I see students do this every year in their exams. They just treat that like it's a right angle triangle. It is not a right angle triangle at all. Now the students who are slightly more switched on will recognize that there is no right angle in the triangle, and they'll try and drop a perpendicular line through the middle, and then they'll use Pythagoras' theorem to work out the height, and then they'll go from there. But the problem with doing that is that by popping Pythagoras' theorem, by popping that perpendicular line into the triangle, what they're assuming is that that perpendicular line is going to perfectly bisect that angle or perfectly bisect a line, and you can't make those assumptions, right? Perpendicular lines do not always bisect and turn the triangle into a perfect right angle triangle with both sides mirroring one another. It doesn't happen unless you've got an isosceles triangle. So you just can't do that. That's why you've got to use a different rule. So write the formula down and know how to use it. So we're going to actually label our triangle first with the three variables A, B and C. Notice A is the angle, B and C are the sides on either side of the angle. And now it's time to substitute into the formula and solve. So if we substitute into our formula, we get half times 2.1 times 1.6 times sine of 32, and that comes to 0.89 kilometers squared because we found area. So that's why we need to have the correct units of measurement. That was a pretty easy example, but what about this one? We need to find the angle this time. We're working backwards, and we're given that the area is 4 meters squared. So once again, you need to remember that it's not a right angle triangle, and it's not something you can just drop a perpendicular line into. You've got to use this formula, half BC sine A. We're going to label our triangle again. A's been done for us, so we're just going to pop B and C on there, and then we're going to substitute and solve. So we know that the area is 4, that's the subject of our equation, and that's going to be equal to half times 5 times 6 times the sine of A. Well, half of 5 times 6 is 30, half of that's 15, so we end up with 4 equals 15 sine A, and sine A equals 4/15 when we transpose our equation. Let's get A all by itself. We need to find the inverse sine of both sides. So now we've got 4/15 on that side, and A is going to be 15 degrees to the nearest degree. So you can see we can also work backwards with the formula. Now for our senior students in extension or methods, you're going to want to know how to derive the rule. So let's consider a non-right angle triangle ABC, and we've actually dropped that perpendicular line right down the center. Now you'll notice that it splits the triangle into two smaller triangles, and this is where a lot of students go wrong because they're assuming that the length from capital A to little b is the same as little b to capital C, and it's not. You can see that clearly here that they're both different lengths, so you can't make the assumption that they're the same. Okay, but we can use some information about the triangles here. We can actually determine the length of H and work out that perpendicular height in terms of the triangle little b, capital BC, which is that triangle on the right hand side. It's a right angle triangle because we dropped a perpendicular line down. So let's find the length of h. So we know that sine of c is opposite over hypotenuse, and the opposite side is h and the hypotenuse is a. So let's rearrange this formula, transpose it to get h all by itself. H will be equal to a sine c. Now we're going to substitute that back into our area formula for a right angle triangle. You'll remember that's half times base times height, but now we know the height is equal to a sine c. So what we can do now is substitute that into our traditional right angle triangle formula, replacing h with a sine c, and then we end up with our new formula for a non-right angle triangle. Area equals half AB sine c. Well, you might want to know what's coming up. We're going to look at Heron's rule next. Then we're going to move on to some senior extension mathematics by looking at the unit circle and trig functions. Get excited about that. And I hope you found this helpful today. And if you did, why not tell somebody? Tell a friend, share it with a teacher, share it on your social. And then why not even share with us in the comments that you found this helpful. And like and subscribe to the channel, hit that notifications button so you'll always know when new videos have arrived and dropped. And you could even follow us on Facebook and Instagram. We've got some cool competitions coming up, so you don't want to miss those. You may not hear about them here on YouTube, so you might want to make sure that you're following us elsewhere as well. And if you've got any questions about anything you saw in this video today, the best place is to send us an email or direct messages through Facebook or Instagram. If you pop it in the comments, it's kind of hard to explain sometimes. I've seen threads go on for quite a while before that person has given up. It's just really hard to explain in a couple of sentences, so the best place is to actually make some contact. And I hope you found this video helpful. My name's Natalie McClutchie. You've been watching McClutchie Maths. Have a wonderful day.